Hi everyone, here we're talking about gravimetric analysis. This allows you to determine the concentration of something or the composition of something by seeing how much precipitate, some solid product, comes from a reaction of all of it. So as an example problem, let's say that you had a coin that was partially silver and partially copper, and you wanted to confirm that it was mostly silver. So you could take a small sample, maybe 0.1264 grams of it, and dissolve that coin in nitric acid. Nitric acid will react with it and turn the silver into silver ions, and then the silver ions will float around in solution. They can then be precipitated by adding some sodium chloride, and when that happens, you get 0.1375 grams of that silver chloride precipitate. So knowing this result and knowing the original mass of the coin that was taken, you can find the percentage of that mass that is silver. So just kind of drawing all that out, you start with this mass of the coin, and then you add nitric acid. That coin was partially silver, partially copper. You don't know the percentages. This is not a 1-to-1 ratio. It's some unknown mixture. So it turns out silver ions then become precipitated along with various other ions. Then you add some sodium chloride solution, and the chloride will combine with the silver and form this silver chloride precipitate. Then you can try to get just this pure silver chloride precipitate separate from all the other stuff, the water and all these other spectator ions, by pouring into a filter which has filter paper. Then you should get silver chloride that's solid collected on the filter paper. It will filter out the solid, and most of the other spectator ions will flow down into the Erlenmeyer flask at the bottom. But perhaps not all of the spectator ions will do that. That's why you need to do a little bit extra wash. Add a little bit extra water to make those spectator ions go down to the bottom, so that hopefully now you have just silver chloride and a little bit of water, and kind of making it wet. And so you again need pure silver chloride to know the mass of just the silver chloride, so you need to remove the water. You can do this by taking this filter paper and placing it on a watch glass. So this is glass, then this is our filter paper with some silver chloride precipitate, and you can heat it in the oven for a couple hours until the water evaporates. You want to heat it enough times to the point where the mass no longer decreases. You've removed all of the water. You know that it's all gone because water has stopped evaporating. The mass has stopped falling. So hopefully now you can find the difference in mass between the original filter paper and watch glass, and now the mass of the filter paper, watch glass, and silver chloride to find just the mass of silver chloride. And now you can convert that into grams of just silver, knowing the net ionic equation for the precipitation. So you had some silver ions floating around in solution. You know that they precipitated as silver chloride. So the net ionic equation would just involve anything else that might have been involved. You know, what that might have actually reacted. So you're forming silver chloride. What else would you need besides silver? Some chloride. So that's the other ion involved. And so you can see that there's a 1-to-1 ratio between the silver chloride and silver ions. If you know how much silver chloride formed, then in moles, you can know the number of moles of silver ions that had been present, and hence how many moles of silver atoms had been present in the coin, and hence the grams of it. So convert from grams of silver chloride into moles of silver chloride, knowing the molar mass of the silver chloride. It's around 140 grams or so per mole. And then there's 1 mole of silver ions per mole of silver chloride, and then per 1 mole of silver ions, there must have been 1 mole of silver atoms in the coin. and then convert from your moles into grams of. Now, to determine the percentage of the coin that was silver, take the mass of the coin at the bottom and the mass of just silver at the top, and then divide by or multiply by 100%. So of the 0.1264 grams of the coin, 0.1035 grams were silver, and so 81.88% of the coin was silver by mass. All right, now a different type of problem. Let's say that you knew that there were a reaction between A and B, and that provided some solid precipitate C. You might have a question, how much C should be formed if you have a certain volume of A and it has a certain molarity, and a certain volume of B and it has a certain molarity. All right, so this is a theoretical yield problem like you were dealing with a couple weeks ago. You have an amount of one reactant and an amount of another reactant, and you want to figure out how much product should form. Theoretical yield. The only thing is, instead of being given grams of A and grams of B, you're given volume of it and molarity of it. So you can follow all the same steps as you would have a couple weeks ago, except instead of starting with milliliters of A, you convert into, actually starting with milliliters of A, you convert into moles of A, knowing the molarity of the solution. Molarity is equal to moles over liters, so moles is equal to molarity times liters. So you can get moles of A and then convert into moles of your C, your product, and go into grams of C, your product. Ditto for B. And the smaller amount of product is your theoretical yield. And the reactant connected to that was your limiting reactant.